Hello, students. So, you've probably all heard the story before, right? Of Galileo goes up to the Leaning Tower of Pisa and goes to the very top, holds off two objects. I think it's like a wooden ball and a metal ball or something like that, or I forget which one, but one's heavier than the other, right? And he holds them up high and then drops them, and what happens? Yeah. So he predicts that they're both going to hit the ground at the same time, and sure enough they do. So let's try this experiment ourselves. What do we think is going to happen? Go ahead and make a prediction. All right, here we go. 3, 2, 1. What gives? What's the issue here? Yeah, air resistance, right? All this stuff here is made of this atmosphere here. It's a fluid, right? It's a fluid, and so as the paper goes down, the air is pushing up against it. So we got to get rid of that air resistance in order to see what it is that Galileo wanted to see. So what should we do? There we go. Surface area, surface area is what air resistance depends on. So if we reduce the surface area, again, we got a textbook here and a sheet of paper. So now, which one do you think is going to hit the ground first? Make a prediction. Here we go. 3, 2, 1. And that's not all. That's not all. So that was one way to do it. That was one way to do it. One of my favorite ways to do it, though, is like this. So we're going to take a paper. We're going to put it like this, so we take away that air resistance. And then again, we're going to go 3, 2, 1. That's pretty cool. So the big thing to get out of this is that in free fall, when objects are only under the influence of gravity, they all fall at the same rate. So all objects fall at the same rate if they're in free fall, which means only under the influence of gravity. So yeah, all things fall at the same rate. All things fall at the same rate when they are in free fall. And free fall is defined as an object only under the influence of gravity. So only gravity is acting on the object. That's what free fall is, so something like this. So there can't be air resistance like you saw in that example. It's only got to be gravity. So you can see here a ball is dropped from rest and all of a sudden it speeds up. So all things accelerate or fall, so there's definitely this acceleration here. We can draw a vector going down there. There's the acceleration. It's equal to g, but it's pointing down, so we call it g, baby g. Baby g is often what we call this, the acceleration due to gravity. So this is the acceleration due to gravity. The acceleration due to gravity. And then because it's pointing down, it's a vector, so it's going to be negative, right? And what the value of g is equal to 9.81 meters per second squared. So that's the value of baby g on the surface of the Earth. So on the surface of the Earth, all things fall at the same rate of 9.81 meters per second squared if they are in free fall, right? If we have the air resistance, that doesn't apply anymore. But free fall, yeah. In this class, we will often approximate g as just being, because we as physicists are lazy, but we often approximate g as being just 10 meters per second squared as opposed to 9.81. So you're free to use either one of these, whichever you prefer. I tend to use 10 because, easier on the math and everything. So yeah, that's kind of the big idea there. And all right, bye.